Hey guys, hello my Cation army. A very warm welcome to your today's amazing chemistry session. And this class is very important because we're gonna quickly revise the last chapter of class 9th chemistry, and that is structure of atom. This chapter is also helpful for you in class 11th. So you know that in class 10th May you have to write the electronic configurations, you have to write the valency, you want to write the chemical formulas. That is not possible without this. Yes, so let's get started. I'm your chemistry master teacher Shilpi Kaushik at Vedantu. And if in case you people are new on this channel, then do not forget to subscribe to it so that you cannot miss on any of the amazing multiple choice question session and series that we are coming up with this week onwards, right? Okay, so let's get started. And if you think about what led to the discovery of subatomic particles, मतलब ऐसा क्या हुआ that people realized that atom is divisible. So you remember Dalton's atomic theory, and Dalton told us that atom is indivisible. He said that atom cannot be divided further to chotu se parts. But then after some time, after like some years, people started observing the presence of static charge in things. Like when you are combing your dry hair, all of a sudden you might feel some charges being developed there. When you are just dropping a woolen cloth very rapidly, then you can see there is some presence of charge, static charge that is developed there. Lightning is happening. So that all these examples led to the idea that no, if atom is neutral, then how is this charge getting developed? How the attraction and repulsion between certain things is happening? So people started observing ki bhaiya, atom is neutral as a whole, but inside atom there is definitely the presence of some charged particles. And Sir Thomson started discovering it. Thomson is like, "Arey, रुको," and it just accidentally happened. Thomson तो कुछ और ही करना चाहते थे. Like he was not intentionally doing it, but when he realized it, okay, yeah, so atom might be there is presence of some charge. So he studied the negatively charged particle inside an atom, and that is something we call as electron now, right? So how he did that, he performed the cathode ray tube experiment, CRT commonly people refer as. So what he has taken here, two conditions: a very low pressure inside the glass tube, and the second thing is a very high voltage. So what he has taken this glass tube, basically discharge tube, and two metal plates he has taken. This metal plate connected to negative terminal of the battery is named as cathode. It has a negative charge. ये वाली connected है to the positive terminal, has a positive charge, and this is anode. He has taken a zinc sulfide screen at the back of anode. Why? Because zinc sulfide screen starts glowing when a charged particle comes and hits on it. Now he has filled a gas inside it. You can take hydrogen, helium, inert gas आप ले सकते हो, that would be better. So he has filled hydrogen gas inside this discharge tube. When he applied the voltage, low pressure, he observed that the zinc sulfide screen that was kept behind anode started glowing. So it means that some particle is coming towards the anode. So he observed a ray, you can say a beam, that was coming from cathode. Because that is coming from cathode, so they were termed as cathode rays, and cathode is the negative terminal. So negatively charged rays are coming from cathode, and they are attracted towards the positive terminal, that is positive metal plate anode. So when some charge is attracted towards the positive side, that means that charge is having a negative value. So he said that some negatively charged rays were coming from cathode and going towards anode. They were falling on the zinc sulfide screen, which started glowing. So these negatively charged particles, their presence was proved. He also studied a lot of property. जैसे इन्होंने यहाँ पर electric field लगाकर देखा, the positive terminal, negative terminal, and these rays were directed towards the positive terminal of the field. So that was also proof that they are having a negative charge, and they also travel in a straight line, and these rays were termed as cathode rays. which are a beam of negatively charged particles, and they led to the discovery of electron. Okay, so more properties we have, like in the regular, in the just the first session of the chapter, we have discussed that in detail. So this is the one short revision. So we would be revising everything precisely, and just we have to revise the complete chapter. So like you have to also be in a proper speed, because a quick revision we are doing. And the next is the proton. Now when I say proton, so यहाँ पर क्या था idea? So you know that if atom has a negative charge, an atom as a whole is electrically neutral. So there would be some positive charge that is keeping it neutral. So these positively charged were studied, the presence of the positive charge was studied by Sir Goldstein, and he has done a very similar experiment. So he has taken a discharge tube, the same conditions of low pressure, high voltage, okay, and the cathode that he has taken is perforated. It means it is having holes in it. This is a normal anode. This time zinc sulfide screen has been kept behind cathode, and यहाँ पर he has filled a gas, and when he completed the setup, when the voltage was applied, this time it was observed that the zinc sulfide screen, which was kept behind the cathode, started glowing. So that means some rays are coming from anode towards the cathode. Cathode पर आ रहे हैं, they are passing through the perforated hole and they are hitting the zinc sulfide screen. Now you think and tell me, if some rays coming to the negatively charged cathode, then what kind of charge it would be having? Positive charge. Yes. So these were a beam of positively charged rays which were coming from anode. So they were given a name, anode rays. ठीक है, हमने इनको क्या बोला? Anode rays. And then they are passing through the cathode and falling on the zinc sulfide screen. Now that was something very much interesting. And apart from that, see, positively charged particles are heavy. ठीक है, so they move slowly. Electrons were having a less mass, but यहाँ पर positive particles are relatively heavier, so they are not able to move as rapidly, so they are moving slowly. So we have taken a perforated cathode, so they can just pass through the cathode easily. Otherwise it might happen that they will just stick there and they might not be able to cross the cathode and hit the zinc sulfide screen. So we have made some perforation over there. That is also increasing the surface area, because it seems like something is passing through a hole, something is passing through a canal. So these rays are also known as canal rays. So this is a very important question that can be asked in your exam. What are canal rays? What kind of charge do they carry? What is their charge? What is the mass in them? The basic properties can be asked, so you have to remember that. And how this is happening, देखो, this is one hydrogen atom, another hydrogen atom. When they collide with each other, then hydrogen has only one electron, so वो electron तो निकल जाता है. So when hydrogen loses one electron, then it acquires a positive charge. So that is how electron निकल कर that start moving towards anode, but the leftover atom becomes a proton, that is a positive charge, and it is attracted to the negative cathode. So this experiment led to the discovery of protons, and finally, quite late in 1932, neutrons were discovered by Sir James Chadwick. Okay, and क्यों ये discover हुए थे? So James Chadwick ने क्या सोचा होगा? See, they were actually discovered to balance the mass of an atom. जैसे I will tell you the basic charge and mass I have written. If you talk about electron, then it has a relative charge of -1 unit. ठीक है, and absolute में actual charge हम पढ़ेंगे. Proton, one proton relative charge is +1. Okay, ठीक है. If I talk about mass of electron, then that is negligible. उसको हम consider नहीं करते हैं, that is very less. And if I talk about the mass of proton, that is equal to unit, 1 unit, मतलब equal to mass of hydrogen. So if you talk about carbon atom, okay, so now carbon is having 6 protons, 6 electrons into it. So ideally the mass of carbon should be 6 unit. because electron have no contribution in mass and 6 proton means एक proton का mass 1 है, 6 का 6 unit होगा. So it means that carbon should have a mass of 6 unit, but actually carbon atom is having a mass of 12 unit. So people were confused कि भाई where is this extra 6 unit mass coming from? Then comes into the picture Chadwick. He said that beta, you are missing something very important, and that important particle was neutron. You can read it here. The data, the entire data is given over here. The actual mass, this is the actual mass on proton, neutron and electron, and this is the relative charge that we have taken. In relative mass इसका 1 unit लेते हैं. Okay, this is also taken as 1 unit, and electron का contribution in mass we do not take. Okay, so yeah, anyway, so he said that कि ऐसा होगा that in carbon you are also missing 6 neutrons, and every neutron is having mass almost similar to a proton, बस just थोड़ा सा neutron का ज़्यादा होता है, slightly ज़्यादा होता है. Okay, just some second digit. So that means 6 neutrons are also contributing in the mass as well as 6 protons. And that is how it comes out to be equal to 12 units. Just one thing ma'am wants to tell you, if you want to be a part of Vedantu regular session, YouTube पर, although we are teaching everything to you, we are covering the topic one shot revision, but unless you know your competition, then you are not actually in the right game. Okay, so we have to be there, we have to fight, like in a way, we have to prepare in a way that we are not just fighting with ourselves, but we are also aware about our competition. You should know that. So test conduct karna, revision karna is very much important, to know your rank during the live classes, to know your performance. So if you will do a rapid revision of the entire syllabus along with the questions on assertion, reason, case based question, then you can be a part of Vedantu's batch for 1 month. Just 1 month ma'am is telling you. अगर आपने 1 month का भी सब्सक्रिप्शन लिया है, then you get unlimited live classes. That means you would be able to complete your entire syllabus. Entire. ठीक है, for both term 1 and term 2, depending on your capacity, you will get plenty of questions and test series. So 30th August is the new batch starting for 9th standard as well as for 10th. 1 month, 2000 rupees worth it. You should never have regret in your life. कि यार, I had a chance in 9th standard, I could have scored 98%, but उस time पर मैंने कंजूसी कर दी. I just like no. Okay, and we are preparing you for how many subjects? Maths, complete science, physics, chemistry, biology, English and social studies. So what else do you need? So you have my coupon code SKA Pro that you can apply, and you will get some 10% extra discount, right? Okay, now talking about the next point, abhi now since the subatomic particles were discovered, electrons, protons, now it was time that we talk about the structure of atom. So let me tell you, when Thomson's model of atom was given, then neutrons were not yet discovered. So which atomic, which subatomic particle is missing in the Thomson's model? That is a neutron. And Thomson said that, have you ever seen half-cut watermelon? आपने watermelon देखा है? Yes, we have seen it. So watermelon is spherical in shape. So how is it related to atom? Atom is also spherical in shape. He said that. Okay. So in the watermelon, you have this red part, red edible part. That is our favorite part. That is just like the positive charge. In an atom also, जैसे ही red color का part होता है, atom में this whole surface is positively charged. Whole surface is covered with protons, and जैसे you have seen seeds in the watermelon, ये जो seeds होते हैं, they are like the negatively charged electrons in an atom. So atom is spherical. On that spherical surface is covered with positive charge. On that positive charge, negatively charged electrons are embedded like the seeds of the watermelon. And the total positive charge will be equal to total negative charge. That is what he stated, and he also called it a watermelon model or a plum pudding model. He compared it in the same way, because he said that total positive negative equal hoga. So that means the model explained the neutrality of the atom. Atom as a whole is electrically neutral, but what were the limitations? That it was a theoretical model. There were no experimental proofs. And all the other experiments that were conducted by Rutherford ने जो किया था, any of the observation was not aligned with Thomson's model. Okay, so that was one point. Okay. Now, if we talk about the next model that was given by Rutherford, and Rutherford was the student of Thomson only. It's like, yeah, I will do it now, but with an experiment. He was like, I'm not much of a theoretical kind of person. So I'm like, I believe in doing the practicals. So alpha ray experiment हम इसे बोलते हैं, in which Rutherford has used the beam of alpha particles. And वो alpha particles क्या है? They are helium 2 plus particle. When you have a helium atom, and helium से you are taking out its both electrons. Helium has 2 electrons, दोनों electron निकाल लो, you will get helium 2 plus nuclei. So that doesn't have any electron basically. So I can say they have a charge of plus 2 unit and the mass is 4 unit. So they are like quite heavy and they're like ठीक ठाक energetic, not highly super energetic नहीं बोल सकते, but yeah, they are energetic. Okay, it means they can penetrate through matter to some extent. To some extent, they will pass through the matter. Okay, then he has taken a very thin gold foil. Why only gold? Because gold is most malleable. So the thinnest sheet is possible when you take gold metal as a foil. That was the thing. And now what he did, this is the gold foil. जैसे ऐसा setup था. Ma'am is gonna show you. This is the gold foil. My drawing is not very good, but this should be like that. It's still manageable. This is the source of alpha particles. Alpha particles यहाँ से आ रहे हैं, some radioactive element you can take. Okay, and यहाँ से alpha rays were made to fall on the gold foil. Gold foil. And around this, he has also taken a screen, zinc sulfide screen. ये क्या है? This I should keep it that way. So you know, ma'am की drawing, ma'am don't try to draw anything. So ये क्या है? This is zinc sulfide screen. So again, whenever a charged particle will come here, it will start glowing. Right? So when the alpha particle were made to fall on the gold foil, then there were certain observations. The first observation is that most of the alpha particles passed straight through the foil. This is the alpha particle coming and it passed straight through the foil. So यहाँ पर zinc sulfide screen started glowing. ऐसे ही more particles are coming, they are passing straight. They are passing straight. And so on. Majority of the cases में they were passing straight. Okay. The second point, what is this first point telling you? What do you conclude from here? If something is passing straight through a space, that means वहाँ पर कुछ भी नहीं है. So the first point concluded was that most of the space inside the atom is empty. खाली है. ये atom है, खाली है. Most of the space. Second point, some of the alpha particles were deflected by small angles. ठीक है, कुछ deflections उनको मिले, जैसे कि if you are having this alpha particle is coming, hitting here, and then it is getting repelled like that. यहाँ पर आया, यहाँ deflection हो गया. Some alpha rays were deflected. It means that some positively charged body is present inside the atom. ये atom है, कुछ positive होगा, तभी तो when this positive helium rays coming, positive collide किया, then there is immediate repulsion. So this point told us that there is some positive charge in the atom, but only few particles were deflected. So that means this positive charge is present in a very small space. ऐसे नहीं है पूरे atom में present है, हर जगह positive नहीं. It might be present at the center. That's present in very small space. Okay. The next observation was that surprisingly 1 out of every 12,000 particles appear to rebound. क्या मतलब है इसका? It means that you have taken 1 out of 12,000 particles. This is coming. It is hitting the atom and now it is getting reflected back by 180 degree. जैसे यहाँ से आया, hit something, repelled by 180 degrees. That means if the positive charge is coming, colliding with something, getting repelled, it has a positive charge. Because repulsion कितना हुआ? Rebound, 180 degree से बिल्कुल flip. That means this body is very heavy. The entire mass of the atom is located in the body, and that is how he said that a very small fraction were deflected, indicating that all positive charge and mass is concentrated in this very small positively charged, which he later on named as nucleus. So Rutherford alpha ray experiment ने क्या discover किया था? Nucleus. So he also proposed a nuclear model of an atom, जिसमें उन्होंने बोला there is a positively charged center in an atom known as nucleus, and nearly all the mass is located in the nucleus. And then he said that ये है गोल गोल nucleus, and electrons are revolving around it like that. And size of nucleus बहुत छोटा है as compared to the size of electron, but there was a drawback. Drawback ये था that if some positively charged body is there in the center and some negative charged body is revolving around it, then a charged body continuously घूम रहा है, it will produce acceleration. If it is producing acceleration, that means there would be some loss of energy. So with each round that electron is making a goal round, it is losing some energy. So point will come when this will jump into the nucleus. Okay, so that means your atom is not stable. So he was not able to justify the stability of an atom, and this led to the failure of Rutherford atomic model. You didn't explain the stability. That was the most important thing. Then who comes into the picture? Then comes Bohr's model of an atom. Okay, Niels Bohr come into the picture, and he was like, okay, dude, I'm gonna give you a solution. That's okay. So he said that electron cannot randomly revolve anywhere. किसी भी orbit में electron cannot revolve. In whichever orbit electron is revolving around the nucleus, this orbit comes up with some fixed energy. So if electron has to revolve in this orbit, then it must be moving with some certain amount of fixed energy. Okay, so it's clear only certain special orbits known as discrete orbit of electrons are allowed inside the atom. ठीक है, ऐसे नहीं कहीं पर भी इलेक्ट्रॉन randomly in any random orbit is there is always the fixed energy का orbit. जैसे let's say this orbit has some x amount of energy, so if electron has to revolve here, it should have a fixed energy. उतना x energy होना चाहिए, and as long as electron revolves in this fixed energy orbit, it will never lose energy. Electrons will not radiate energy. Okay, so these orbits are also known as shells, या फिर you can call them energy level, and they also were represented ऐसे. जैसे first energy level will be K shell, then second is L, this is first, this is second, this is M shell, third shell, N is the fourth one, and so on. ऐसे revolve कर रहा है in a fixed energy, and he was able, and although there is a lot more to Bohr's model that we study in class 11, but right now this much information is sufficient, right? Okay, the next is electronic configuration valency. So now we know that how electrons are revolving around the nucleus in an atom, but are we aware how these electrons are present inside the atom? Do we have any idea that this is nucleus? Now let's say there is the presence of 20 electrons in an atom, then how those 20 electrons are arranged? No, arrangement nahi pata hai, and that arrangement of electron is something that we call as electronic configuration, that was given by Bohr and Bury all together. And iske liye there are three basic rules. The first rule is that the maximum number of electrons which are present in a shell is given by the formula 2n square. Maximum electrons that I can put in the K shell, L shell, M shell, बताओ, देखो 2n square, n value is 1, so 2 into 1 square, that would be 2. N value is 2, 2 into 2 square, that would be 8. यहाँ पर 18 and so on. So you can put that n as your shell number. The second rule of the scheme says that the outermost shell cannot have more than 8 electrons. So you have to make sure जब भी configuration लिखो, the valence shell. Let's say I am filling the configuration like this. ये 9 electrons नहीं आ सकते यहाँ पर, ठीक है? So you cannot put more than 8 electrons in the outermost shell because that will disturb the octet rule, that is the stability criteria. अगर वही आपने disturb कर दिया, then what are you doing exactly? Yes, okay. Then final point is that electrons are always filled in a stepwise manner of energy. So first of all, K shell should be completely filled. ठीक है, once K is completely filled, you will go to the L shell, then M, and so on. ठीक है, so first of all, electrons have to be put in the lower energy level, then L में जाओगे, M में, ठीक है, ऐसे नहीं है randomly कहीं पे भी you will put the electrons. So let's take the example for the chlorine. Chlorine is having an atomic number of 17. 17 protons, 17 electrons. So I have to fill in the 17 electrons. I will start filling the K shell. Maximum capacity 2. I will go to L. Maximum capacity 8. I will go to M. 7. 2, 8, 7 is the configuration for chlorine. ठीक है, practice करना. In the comment section you will write the valency of potassium, and I have told you this in the regular session also. Atomic number is 19. I want the answer from each one of you who is watching the video right now in the comment section. Okay? Yes, and I will read your comment. Chalo. The next point is, what is valency? So you have heard this in chapter 3 also, combining capacity of an atom. So what is the meaning? So that is simply the number of electrons which an atom gains or loses or shared, so which can lead to a completion of octet. Octet achieve करने के लिए atom can go to any point. Yeah, they are ready to gain the electron, lose or share, and that number of electrons gained, lost or shared is the valency. ठीक है, in order to complete the octet, that is telling me the combining capacity of an element. So how one atom is making a bond with the another atom of some element. ठीक है, जैसे कि let's say you have to find the valency of chlorine. Okay, chlorine 287 is the configuration. So you can see that chlorine is having how many valence electrons? 7. 7 valence electrons है. So chlorine only require 1 electron to complete the octet. है ना, एक ही electron चाहिए octet completion के लिए. So its valency is 1. You can also do it like that. Simple trick you can follow, and I have also shared a scheme with you. See the valence electron. If valence electron is less than equal to 4, then valency is equal to valence electron. If valence electrons are more than 8, then valency is equal to 8 minus valence electron. ऐसे भी कर सकते हो, but you should be fluent with the configuration. So that is again second homework. What is the valency of magnesium and aluminium? Okay, you can do it. Now let's go to the next topic, that is the isotopes and the isobars and the applications. So this is very important. इससे पहले I hope you know about atomic number. When I say atomic number of carbon is 6. Atomic number is the number of protons which is present in an atom. That's it. कितने protons है atom में? That is the atomic number. So if carbon has atomic number 6, it means carbon is having how many protons? 6 protons. And denotation is done by capital Z. Okay, so that is simple written. And if you are asked about the mass number, बताओ mass number क्या होता है? Mass number is where exactly the mass of an atom is lying in the nucleus, है ना? And nucleus में कौन होता है? Neutrons and protons. So mass number is the total number of neutrons and protons in an atom. ठीक है, आप बोल सकते हो nucleons. Nucleons is the term that is used collectively to represent protons and neutrons. Protons and neutrons को collectively बोलते हैं nucleons. Okay, and they are present in the nucleus of an atom, so you know that. So when I say mass number of carbon is 12, that means it has 6 protons and 6 neutrons. So दोनों ने 6 का mass में contribution किया है है ना? So you can do that. चलो, mass number is also easy. How do I give the notation of an element? Representation में किसी element का कैसे करती हूँ? I am having, first of all, I will write the symbol of the element, जैसे carbon C. In the subscript we have to write its atomic number, जैसे atomic number कितना है? 6. Number of protons, and then you will be writing the mass number, 12. Simple. Atomic number in the subscript, mass number there. Numericals can be asked from this portion, so remember that. Keep that thing in mind. Okay. The next is isotopes. So isotopes में क्या होता है? Isotopes are basically, let's remember Dalton ने बोला था that if you have a carbon element, then all the atoms would be having same mass and same properties. That is what he told us. But if you talk about the isotopes, क्या ऐसा हमेशा होता है? After some time this postulate was rejected, ठीक है, because it was observed that carbon के atoms can have different masses. Atoms of the same element, different masses. That was quite surprising. And these species were named as isotopes. जैसे if I talk about the hydrogen element के ही some hydrogen atoms can have a mass of 1 unit. Some hydrogen atom can have a mass of 2 unit. कुछ का हो सकता है 3 unit. But they all are from the same element, that is hydrogen. सबका atomic number देखो same है. Atomic number 1, 1, 1. So they are isotopes. So you can remember same atomic number but different mass number. Mass number is represented by capital A. Okay. Protium, deuterium, tritium. And also कभी पूछे name an atom which doesn't have any neutron. कोई ऐसा element का कोई atom, that is protium. Protium में there is 0 neutron. Okay, so you can define it the same thing, same atomic number, different mass number. There are 2 ways to define it, but remember one thing about them, that isotopes are having the same chemical properties. ठीक है, केमिकल प्रॉपर्टी सेम होती है बिकॉज दे हैव सेम नंबर ऑफ वैलेंस इलेक्ट्रॉन्स. एंड आइसोटॉप हर एलिमेंट का इज ऑलवेज अ प्योर सब्सटेंस एंड इट डिपेंड्स ऑन द एलिमेंट. सम एलिमेंट्स हैव आइसोटॉप्स इन नेचर, सम कुछ के नहीं भी होते हैं. सो इट्स नॉट नेसेसरीली दैट एवरी एलिमेंट विल हैव आइसोटॉप्स, राइट? ओके, नाउ द नेक्स्ट थिंग, मैम, there is one confusion. जैसे I am talking about chlorine. Chlorine is also existing in isotopes. Chlorine के ही atoms have a mass of 35 and 37. So the fight over here is that which mass of chlorine will I use? Shall I take chlorine as the 35 mass or the 37? So there should be a universal criteria that is common to each and everybody. Isn't it? ऐसे थोड़ी I can take 35, you will take 37. No, it doesn't work like that. So we have to have some common grounds, and for that we introduce the topic of average atomic mass. So we have to take the average atomic mass. When I say average, that doesn't mean 35 plus 37 divided by 2. That would be the wrong way to take the average. So यहाँ पर एक point होता है, that is the natural abundance. We have to see the percentage of every element in nature. कि in nature in what percentage it is actually existing. जैसे कि I am talking about chlorine 35, that is experimentally determined. This exists in 75% in nature. Chlorine 37 के atoms exist in 25%. मतलब out of every 100 atoms, 75 atoms are of chlorine 35 and 25 are of chlorine 37. Okay, so how do I take the mass now? तो सोचना पड़ेगा what is the right way to take the average atomic mass. So you have to keep the abundance into the picture. ठीक है, आपको abundance को ध्यान में रखना है. So इसके लिए what we would be taking, simply देखो, I am telling you here, chlorine यहाँ पर लिखते हैं क्लोरीन 35 मास कितने परसेंटेज में है? 75%. यू ऑल कैन सी मैम. क्लोरीन 37 मास कितने परसेंट में है? 25. ओके, सो आई एम टेकिंग द एवरेज एटॉमिक मास. सो टेक 35 unit mass 75, means 75% of chlorine atoms have a mass of 35 unit. Okay, plus 25% of chlorine 37 mass के atoms are there. बस क्या किया मैम ने, in 75% chlorine atom having a mass of 35 are there, in 25 chlorine atom having a mass of 37 are there. So that would be like 75 into 35 plus 25 into 37 divided by 100. That is a basic way to do it. ठीक है, ऐसे आप कर लेना, you will get the mass equal coming out as 35.5 units. Very simple. Okay, so practice that for bromine. I want each one of you to do that. So these are some of the applications of isotope. So isotopes अगर ना होते, then so much advancement, especially in the field of medical sciences, would not have been possible. We have the cancer treatment possible because we have isotopes. So when we have energy and we use it in the positive way, then everything is possible. It just depends on the inclination, हम कैसे उसको use करते हैं. So isotope of uranium is used as a fuel in nuclear reactors. ठीक है, यूरेनियम का आइसोटॉप is used as a fuel in nuclear reactor, uranium 235. Okay, nuclear fission reaction होता है, and then the energy, like basically uranium 235, it breaks down to smaller nuclei of krypton, barium, and large amount of energy. Some 3 neutrons are also released. So that energy we use to make basically electricity in thermal nuclear power plants. ठीक है, nuclear power plants में हम use करते हैं. So that is used as a fuel. Homework question: can I use uranium 237 in the nuclear reactor? Why not? ठीक है, I am watching closely how many of you are watching the entire session. क्या सारे homework answers मिलेंगे in the comment section? That depends. Let's see how many of you watch it carefully. Okay, the isotope of cobalt 60 जो होता है, that is used in the treatment of cancer. It kills the tumor cells जहाँ पर भी accumulation of charge like cells होगा body में, that would be disrupted. And isotope of iodine is used in the treatment of goiter, that is swelling of this thyroid gland over here. This is used. Then carbon 14 को use किया जाता है for the age determination of the fossils. आपको कोई पुराना animal का bone मिला, some rock you got, tree, so you can just know their age with the help of the method. The next is the isobars. Isobars क्या होते हैं? So again talking about the model of the atom that was given by, remember, yes, Dalton. So उन्होंने बोला था atoms of different element will have the different masses, but no, that is not the case. There is a possibility that atoms of different element can have the same masses. जैसे you have argon, calcium, आप potassium की बात करो, they are the atoms of different element and they all have a mass of same 40 unit. सबका mass same है. ठीक है, so when atoms of different elements have the same masses, we call them isobars. Example ma'am has told you, देखो 40 40 40, yet they have different atomic number, their nucleus is different, they are from the different element, yet having the same masses, isobars. Okay, and isotones भी होता है जिसमें same neutrons are there. So I am giving you a homework question. You have to tell me, if K and L shells of an atom are filled, then what would be the total number of electrons in the atom? Ready? So I know you all can do it, and again reminding you of the VIP subscription that you get a guarantee if you are enrolled with the full year program with Vedantu, and 1 month के लिए भी you are getting unlimited live classes starting from 30 August, and do not miss on to the subscription. That is very much important beta. ठीक है, for 1 month one time chance is there. एक ही बार 9th class आएगा, हर रोज नहीं आएगा. So SKA Pro is a coupon code that you can apply, and you can join the Telegram channels from the link in the description box. If you have any issue, you can reach out to me anytime on Instagram. Thank you so much for attending the class, and do not forget to like the video, hit the subscribe button as well, and the bell icon. Ma'am, will see you next time. Take care.